Python is a programming language, and I have almost no idea how to code. But it's possible to make some sick animations with it, like text writing itself on the screen, or this brain image appearing and then turning into Uranus, the planet. So to make my videos more je ne sais quoi, I started learning how to make these around a year ago. That's pretty cool. The problem is that I stopped, and I only have the basics down. I've spent 10 minutes doing this. But yesterday I saw this animation.
And you typically think about it as a combination of many different pure sine waves.
Okay, I want to know how to make this. So by the looks of it, this is just a random wave that then transforms into a bunch of sine waves. I'm pretty sure this maneuver is called the Fourier transform. That's a lot of symbols. Because any wave like this can be divided into a lot of sine waves, but I have no idea how to do that. So first, instead of trying to create this monstrosity, I'm just going to try to create a normal sine wave. Let's start by creating a new folder, waves, and then a new file within that folder, which I can't even do because it's macOS. Great. Let's do that from the terminal. Waves.py. Boink. And there it is. Open it with Visual Studio Code. First things first, I'll need to import the library that will let me create the animations. So from Manim import Snowflake. This is the library I'm talking about. It's called Manim. Next, I need to tell Python to create a new animation file, and I can do that with 2 lines. The first one is class, then the name of my animation file, which will be waves, and then in parentheses I'll say scene. Perfect. And then def construct self. Beautiful. Now all the code that I'll write inside of here will be our animation. Right now it's pretty empty, so let me try to create the sine wave. I mean, Google how to create one. Manim create sine wave. How to animate a sine wave with decreasing period. Oh yes, I first need to create an axis and then put that sine wave onto the axis. Beautiful. And for that, I'll also need the NumPy library. Import NumPy as NP. Beautiful. So I'll say A is equal to my axes. This will essentially just put a pair of axes onto the screen, which I forgot how to do. So I'll just yoink it from here. Boink. And I'll also need the sine function. Yoink it from here as well. Boink. So I'll say plot this function onto the A axis. A is the axis for me. And I'll call all of this the graph. Okay. Self.add graph. And let's see what we get. Waves. Oh, those actually do look like waves. Let's continue. I want to also add my axes onto the screen so that I can see where they are. Okay, so my y-axis is going from 0 to 10, which I definitely don't need since the sine wave goes to 1. So we'll just say 2. And let's do the x range from -10 to 10. What happens now? Ooh, okay, let's make that symmetrical. There we go. Now, if I just remove the graph, we should be able to see a simple plain sine wave. And in the video that I want to recreate, it's white. So let's make it white. Boink. Beautiful. Now, what I'm thinking is, what if I turn this sine wave into a bunch of other waves by just adding a bunch of other waves? For example, plus np dot cosine x divided by 2. What happens now? Oh, that's promising. Okay. Wait, I think I know how to do this now. Let's add some more functions here. np dot sine x divided by 3 perhaps. And then I can say x divided by 4.5. What do we get now? Oh, this is shifting a little too much. What if I make the range of my axes like -100 and then 100? This should give me a bigger wave. That's my pulse. Instead of x divided by some number, let's maybe do x times some number. Does that give us anything good? Whoa, maybe smaller number. 0.69. Okay. Oh, that got simpler. Not the best. What about now? Okay, it's definitely weird. Let's increase the y range as well. So from -4 to 4. Oh, okay, we can work with this. Let's do square root of x. Does that work? Probably not. How do you do square root in Python? I need math. So let's also import math, and then over here say math.sqrtx, and we get an error. So I didn't have sufficient math. Okay, does this look any similar to this? No, that's probably because my x range is too big. So let's do something like 50 instead. Okay, that's pretty similar to this. Well, just the wave. By the way, I know that 3 Blue 1 Brown, the creator of this video, by the way, you should definitely give this a watch. I know that he always links to his code in the description, and he makes these animations with the Manim library, which, by the way, he created. No big deal, I know. But I will not look at his code until I try to recreate it myself. For now, let's ignore that this is 3D. I need to now split this wave into all of these separate components, and they should have different colors like this. That looks so cool. So the first thing that I need is to probably create variables for each of these. I'll call the first one S1 for sine1, and then copy this. And then I will plot only this function onto the same axis. But since I didn't add it on the screen yet, it will not be visible. Only this thing will be visible. And then I'll transfer transform from this function into all of these separate functions, which will remove this one on the screen and show all the other ones. Makes perfect sense, I know. So let's do a.plot, which essentially lets me create a function, and I'll say np.signX. So now I have this function here saved as s1. And essentially this function, this wave, is made up of a bunch of these functions, this one, this one, this one, and all the other ones. So right now I'll just copy this, paste it a bunch of times, and instead of sign X, I'll say this essentially. Also in VS Code, if you hold Option, you can click down and add multiple cursors, which is really cool if you want to delete a bunch of stuff in different lines. Something happened here. So now all I have to do is copy this and paste it here. This video is also a great excuse to practice my Vim skills. You can see me jump around like this without using my mouse, and I'm trying to practice so I can learn it. So essentially, instead of selecting text like this, like an average mortal, by holding Option and Shift and using arrow keys, what I can do is click Escape, then click L to move right, V to enter visual mode, click F and then closed parentheses, which will select everything, click Y to yank this, go back here with J, go left with H, and P to paste, and even do it incorrectly. What a flex. Wait, how many waves should I use? How many were in the video? 1, 2, 3, 8, 9, 10. I think there are 10 waves here, so I need 5 more. Yoink. Oh, I'm struggling so hard with Vim key bindings. I want to select backwards, so I'll do V for visual mode, capital F, and then N, and then semicolon, then Y to copy, J to go down a bunch of times, W, W, L, and then P. And the bracket is on the wrong side. Great. Ooh, I can do it more efficiently. V, and then the underscore, and then right twice. Is that more efficient? Probably not. Please ignore this if you've never used Vim. Now I just need to update all of these numbers so that they're not the same variable. Okay, so now this graph is this wide graph that's made up of all of these sine waves and one cosine wave, and then all of these functions plotted onto the same axes, or just different sine and cosine waves that make up this function. So now in theory, I should be able to transform from this one into a bunch of these waves, right? First, I think I need to put them into a group. So I'll say G equals V group, and then put everything inside the V group. So now if I come here at the bottom and say self.play replacement transform from graph into G, it should technically transform this wave into a bunch of these waves, probably, because they're all in this G group, but for some reason isn't closed. Wait, do I need to indent these more? Why is it underlining this open bracket? Because I closed it down here. Oh, because these are elements in a group, I need to add a comma after each one. Makes sense? Now it's good. So let's try to run this and see what happens. Got an unexpected keyword argument, S1. Okay, interesting. So why does it not like S1? I should probably just say G is equal to V group and then put all of them separately like this. This should then probably work. I'll also add a self.wait command at the end so that the animation pauses for 3 seconds once it finishes. Please be nice. Okay, did not think about that. All of my sine waves have an amplitude of 1, which is not the best. What if I do +2? Does that change something? No. Wait a minute, let's open Desmos. F of x equals sine x. And so how do I make it go up to 2, for example? Oh, now it's 2. Okay, so essentially instead of doing this, x times 2, I have to do it here. And now it doubles. Great math knowledge. Okay, now they all have a different amplitude. Let's see how this looks like. Oh, let's actually undo everything and look at the video. But the waves in the video seem to have very similar amplitudes. I'm realizing now that I should probably times all of these with the same number, but I'm lazy to do that, so I'm disrespecting the Fourier transform, because the sum of these waves isn't actually the wave in the beginning, this one. Ooh, look at this cool effect. Now I think I need to make all of these a different color, for which I'll use the color attribute. Ooh, actually I have no idea how to use functions in Python. So I'm going to try to create a function that sets a color for a graph. Whoa, what just happened? I might have inserted 50 lines. That's how vast my Vim knowledge is. Okay, so let's start with Googling functions in Python. I think you started with def. Yes, def my function, print hello from a function. Yoink. So let's say def color. Should it light up green? Function color? No. Okay, that's good. And then inside of parentheses, I think this is a place where I input something. So in this case, I'm going to send S1, S2, and so on into the function. So I'll say X, hopefully. So what does the function do? X dot set underscore color to random bright color. And then it should return X, right? Maybe. Okay, so let's copy fun color. How do I copy with Vim? Yoink. And then down here, I'm going to say fun color and send in S1 inside of fun color. And if I either of the functions change color, it worked. Oh, definitely didn't work. Manim color only accepts int, so it doesn't like that it's a function that's plotted onto an axis. Okay, what about a function that sets color for this entire group? So in this case, I would need a for loop inside of the function. So for I in range length g, so the length of the group, or actually in this case length x, since we're only working with x, let's say x dot set underscore color random bright color. Does that work? Oh, I didn't include it here. Never mind. Fun underscore color g doesn't work. Great. I want to know if this function works at all. How do I test? Maybe it's not set color, but dot color. Function color g. Does that work? Manim color is not callable. Okay. For attribute, comma, value in something, print attribute slash value. Okay, let's try to do this. Let's delete the fun color from here. And instead of doing all of this, let's simply paste in this. Okay, for attribute slash value in this will be G, right? Do I need the parentheses? Okay, let's try this. It should print out a bunch of things. Run Python file. Module numpy has no attribute float 64. What if I add these? VGroup object is not callable. What if I do S1, not callable? Okay, no idea what that did. You know what? Let's nicely set the color ourselves without any programming shenanigans. Color equals random bright color. This should work. Oh, so I just needed parentheses here and now it should work. Those are now colorful. Okay, so the problem wasn't with the function. It was with this random bright color, and it's that I needed to add empty parentheses at the end. So now if I come here and say function color G, it should run the entire group through this function, which goes through every element in the group. And since all of these sine waves and a cosine wave or elements in this group, they will each have a different color. In theory, Manim color object is not callable. Set color? Wait, I think it's working. Okay, every single wave now became one color. So I think this return needs to be indented here, right? Wrong. Okay, first, instead of a random bright color, let's use random color. So they're not as bright, just like me. And now they're all green. Why does it change? For I in range length x, x set color. This should be I set color. Or for I in x, I set color, and this doesn't even have to be like this. Now in my head, this should definitely work. I'm a genius. Learned to use a function, ladies and mental gen. Beautiful. So now I have all of these waves that this first wave turns into. There's a lot of them. They're very tightly spaced. So I'll decrease the range, -20 and then 20 here. Let's see how this looks. Ooh. And by the way, the colors are different every time. Beautiful. I mean, not super beautiful because most of them are black now. Let's actually create an array with a bunch of colors. So let's say colors equals red. And so for I in X, we're going to set a color from one of these colors. So for J in colors, I set color, delete everything here, colors J. Does that work? List indices must be integers or slices in range length colors. Does this work? No. So why is it all purple? Let's try to run this one more time. Oh, it's blue C, so it gives me the last one. Why? For I in X. Oh, so this is trying to set the color of I with I itself. In this case, I isn't 0, 1, or 2. It's actually this entire S1. That's why it doesn't work. Genius. So I do need two loops, probably. So what if I do range length X like this, and then the ith element of X set underscore color, colors I, Captain. Okay, this might actually work. Yes. Oh, I'm so happy the function works. Beautiful. That's the easy part because I expected to get to this point somehow. However, you'll notice that in the video, this function actually moves and then it transforms as it's moving. Well, actually, it stops before it transforms. It stopped and then it transformed into a bunch of these moving functions. So now somehow I need to make all of this move and also put everything into 3D space. For that, I think I should use what's called a 3D scene. Very original, and I don't fully remember how to make the camera move from its original point. So let's see. Oh, I need to use a 3D axis instead of just 2D axes. Thankfully, I only need to fix it here instead of everywhere. That's good. And now here it says self-set camera orientation to this. I used to know what phi and theta means. I think this is horizontal rotation and this is vertical. That's most definitely not true. Okay, and let's try to see this now. Oh, okay, that's a rubber band pancake. Let's see what this phi does, or phi. Should be a different pancake. Oh, yes it is. Let's also add the axes on the screen. Self.add A. Oh, okay, that makes a lot more sense. So this is the x-axis, which is turned around. So what if I just slightly change the phi to maybe 80? What happens now? Now there should be names next to these axes, so I know which one is which. Ooh, this is the y-axis here, and that's the x-axis. So the z-axis is pointing down. Now in the video here, the x-axis is pointing there, which is where my x-axis is currently pointing. Probably should be pointing somewhere there, and my camera is way too much up. I'm going to decrease this from 30 to 10. Yes, beautiful. Let's increase the zoom amount a little bit. Okay, so my x-axis is pointing there now, and in the video it's also pointing there. However, my y-axis is pointing this way, whereas in the video it's pointing up. So I need to rotate the screen to the right, which I'm pretty sure I can do with theta here. Oh, what happened here? X is there and y is here. Oh, I'm completely lost. Getting slightly closer, not much though. Now I need to move the camera over there somehow. Everything is just upside down. This part is not even supposed to be that hard. Right now, the z-axis is pointing right at me, right? That's why it's 0. So if I decrease it, it's going to point the camera there. And if it's in radians, means I need to do like 0.06. No, that's the wrong number. Needs to be a positive number. Ooh, wait, it's happening. It's happening. It's slowly happening. Okay, 0.1. So phi is in radians. A little more, just a tiny bit more. So it's all about the movement around the z-axis. In this image, z is pointing up, and in my video, it's pointing down here. So phi is the angle between the z-axis and camera through origin. Okay, let's ignore that. I can just rotate the axes. Not sure how that's going to improve things. How are they even rotating? Maybe not the best idea. Ooh, I found this interactive math thing. Okay, so this red ball is pretty much my camera, I think. And so I want my y-axis to be vertical and x-axis to be there. So how do I do that? I have no idea what I'm looking at. Oh, I can rotate this entire thing around. Oh my god. Boom. This is what I want. So now the camera would be here. This is exactly the same as the video. This is the z-axis, which is this here. The y-axis is in the center, and the x is there, which is here as well. Maybe slightly like this. So now the camera is here, and what are these values? Don't tell me I will have to convert this into degrees and radians. I probably will. After around 2 hours of trying to make this look the same way as in the video, I have decided that I like this angle more, so I'm going to stick with it for now. With this one, you can still see all the waves appearing on the screen, so we can work with that. The next thing I need is to make this wave move. So in the video, before the wave transforms into a bunch of little waves, it's actually moving on the axis, like this. Then it briefly stops and transforms into a bunch of waves that are also moving. So let's figure out how to make them move. Wait, let's go into Desmos and see what makes a sine wave move. 0.1, 0.2, 0.3. Yes, the wave slightly moves if I change this number. Okay, so next to each one of these x's, I need to add a number that's changing. I think to create a changing number, I have to use a value tracker. So I'm going to say n is equal to value tracker. No. I'm going to say it's equal to decimal number, and then that number will be... Wait a minute. I completely forgot how to do this. I know where to find it because I made a course for beginners about Manim, and I definitely talked about how to do this, but this was a while ago, so I can't remember anything. What a great product placement. There we go, value trackers. Let's see it.
Next, let's talk about a thing.
Oh, who's that guy? Oh, okay. Thanks, me. So yes, I do need to create a value tracker and say that its original value is 0. And then I'll say that this decimal number is t.getValue, which means it's basically whatever's inside the value tracker, and I can animate the value tracker changing. So in this case, from 0 to 10, which would change the phase of the wave. And now next to each one of these, I need to add the n. Let's see how this looks like. Oh, setting an array element with a sequence. This requested array would exceed the maximum number of dimensions of 32. What do I have to say about that? I'm doing the same thing. t1.animate.setValue to 30, and the value before is 10. What's the difference between that me and this me? Oh, I think I need to add an updater to each of these functions. I don't remember how to do that. There we go. I need to say always underscore redraw, then lambda, and whatever I want to update inside there. Okay, so instead of selecting with my mouse, let's do a quick Vim movement, Shift V, then down. Nope. How do you enter visual block mode? Never mind, let's just select like this. We'll say always underscore redraw, then open parentheses, lambda. Now everything here should be always redrawn on the screen, which will probably make this work, I guess. No. Setting an array element with a sequence. Okay, let's copy this and investigate. So instead of creating this decimal number, I think here I'm just going to do t.getValue. Maybe this works. Oh, it's creating it. Okay. So now in theory, these waves, instead of staying still, should move over a period of 10 seconds. And this will definitely take a while. Whoa, it just turned white. Why did that happen? Oh, my original value tracker is set to 5 and I'm animating it to 5. Great. That's why it's not moving. And let's wait for another 52 years. Actually, to not wait 52 years every time I rerun this, because I'll probably rerun this multiple times, I'm going to create a new file, save it next to my Python file, and call it manim.cfg. That will let me set the resolution of this file. So quality equals, oh, okay, they're moving, not to the right side and very slowly. Okay, let's set this to -20 and see what happens. You know what, maybe -40. But why do they turn white all of a sudden? Anyway, let's set the quality to low quality, then rerun this animation. We should see some horrible quality. Why does it name it manim.cfg.c? It shouldn't be called C. Okay, let's rerun. Now the quality should be low. Yes, it's doing it much faster. The waves are moving, but the color is still the same. Okay, I can set the movement to linear, I think. Pretty sure I have this in one of my projects, 3.py. There we go. Rate func equals rate functions and the function name. Yoink. Beautiful. And instead of ease in sign, let's do linear. This should work better. Okay, now they move linearly across the x-axis, which is very nice. How do I get the color back? I mean, I could definitely set the color for each of these here, but then I wouldn't be using my cool function that I made. Okay, I'm not using my function. Let's delete it. And then let's add each color here. Now this should definitely work. Oh, always redraw got an unexpected keyword argument, color. Maybe I didn't put it in the right parentheses. This is definitely how an actual programmer would do things. Okay, it works. So now the colors should also update with the functions and we should get the colored versions. Yes, all right, that's cool. Okay, next in the video, the actual white wave is also moving before it transforms into a bunch of other waves. And the camera is also rotating, and the camera stops, and then this one transforms into a bunch of other waves. Why did I make that sound? Let's see what we get in this super high resolution 4K preview. There's the wave. Okay, why is this wave not moving here? Oh, it's because... Okay, so first it will add the graph, then it will animate it so it moves, then it will transform to a bunch of other waves, and then they will start moving, hopefully. Oh boy, well, it's gone. And these ones stopped moving as well. Very interesting. Why did that wave just go down? That's not where I'm supposed to put this. I'm supposed to put this inside the parentheses. So here, yes, let's do that again. Yes, okay, this is moving now. Looks weird. And these now stopped moving. Oh, it's going. Why is the amplitude so big here? Okay, I don't like that it does this little boop jump there. How can I prevent that from happening? Because here in this video, this is such a smooth transition. It goes like... Wow. And my version sucks. Almost as if these waves are separated on the z-axis. Wait a minute. Oh. look at that. That was so cool. Damn, that's cool. Exactly. Okay, let's stop looking at this and go back to my perfect creation. Okay, I have two problems. These waves for me aren't separated on the z-axis, and there's a little jump when it transforms to all of these. In the video here, it happens insanely smoothly. How the hell? You know what? At this point, I'm going to look at the code. Don't judge me. All the code for specific videos is visible here. Okay. Which date was the video released? 2023. So let's go in here. And the video is Optics Puzzles. Optics Puzzles. Okay. Now, which one of these will have this animation? It says linear polarizer. So let's open every single one and search for that word. Oh, there it is. Polarizer label equals linear polarizer. Beautiful. So it's inside of the cylinder code. Are there any more linear polarizers? No. Okay, so this is the one. First line, I immediately don't understand what this means. Okay. So this just adds the label to the start, which is where? This here adds this label here that rotates alongside everything. So what's that everything? Polarizer label is next to polarizer. I think I need to find the polarizer. Polarizer is equal to polarizer. Ooh, I found many waves, and he's putting them into a V group, and each wave is called oscillating wave. Does that exist? Oscillating wave Manim. Ooh, I think I just found how to move a function on the z-axis. Instead of creating just a normal curve, I need to create a parametric function, and then here this is x, y, and z. Okay, so everything here changes. Not sure what's going to happen if I run this, but let's try it. All the input array dimensions except for the concentration axis must match exactly. What? Very interesting indeed. Okay, instead of doing this here where it will screw everything up, I'm going to leave this here and just create a new animation and experiment with the wave. How I can make one wave transform into a bunch of waves, because this will get cluttered real fast. Let's see what this gives us. Oh, just a little thing. Interesting. In the video, there's also a axis config going on. So let's do that as well. Or let's just do the default axes equal 3D axes and copy the camera orientation from here. Okay. What if we don't do any sine curves or anything? Let's just do 3x2. No idea what this will do. Oh, there's a little stick. Interesting. There's also t_min and t_max. In this case, it's x min and x max. Okay, let's do that as well. Like this. Got an unexpected keyword argument t_min. What's a parametric function? In mathematics, a parametric equation defines a group of quantities as functions of one of more independent variables called parameters. Good to know. What is going on? How did I end up watching this? Okay, so what I've learned so far is that I have no idea what parametric functions are. That is not great. Okay, I'm overwhelmed. Let's return to this here and see maybe we can wiggle our way through this animation without having to use parametric functions. What if instead of having this wave transform into those little waves and only then start the movement, what if I do it at the same time and also transform the first wave into each of these rather than a group? This might work. Oh, so now I see why it jumps. The phase of the wave jumps after the transformation is finished. As it transforms from here to here, the beginning of the sine wave ends up here, and then it jumps up. Why does it not get the phase, though? Ooh, maybe I just got rid of the jumping problem and introduced 50 more problems. Yes. Okay, now it just transforms and there's no jumping around. Okay. At this point, you can definitely tell that I've hit my skill ceiling. I'm struggling. Everything's become 100 times more difficult than in the beginning. If I give up now, I don't think I've learned anything apart from making a cool function. Okay, how do I do this? Okay, what if here, instead of t, it's going to be t1 and I'm going to animate them separately somehow. Let's try this. Oh, this is definitely great Vim practice. What if I change this to 0 now? The functions should not jump, probably. Does it jump? No. Okay, that's good news, I guess. I don't know. I don't even know what I'm doing. Why are these waves not moving anymore? T, set value to -40. Okay, so let's make this 0 as well. Now, if they don't jump as soon as the transformation finishes, we are good. We've solved one of the problems. Please work. And the moment of truth. There's no jumping around. Let's go. Let's go. Okay, we're getting closer. There's no no more of that jumping as soon as they transform. They just ease in nicely into the movement. And let's change this from linear to ease in sine. Now they should move nicer in the beginning. I'm happy about that little bit of progress. Not going to lie, I was about to rage quit there when I was talking about learning. Okay, there we go. And nicely just ease into the movement. Ooh, beautiful. That is pretty good indeed. I haven't yet figured out a few things. One is how to move these waves left or right onto the z-axis. Wait, maybe I know how. Isn't there a thing called the z-index? Z-index Manim. Period z-index equals to -1. So let's change the z-index of either of these to -1. Does that work? All subobjects of V group must be of type VMobject. What if I do that here? S1.z-index equals -1. Does one of the waves move on the z-axis? It should move further back. Anyway, so that's one of the problems. The next problem is that it doesn't transform nicely just like in the video. It transforms sort of weirdly. In the video, as the waves are transforming, they sort of sprinkle out and start moving once they transform. And in my code, they just transform, then start moving, which is definitely lame. Okay, here we go. Is one of the waves further back? No, they're not. Oh, wait, here there's a dot that moves on the z-axis. How? It's the blue dot. This one, the right dot. Tell me where. Dot shift right. This is the z-axis. The green one is called out dot animate shift out. You can shift it out. That means z-axis. Yes. Shift out times 2. Does that work? Wait. No. I need to put this inside of always redraw. So here. Okay, now one of these, S1, should be shifted on the z-axis. Please work. I'm going to be so happy if this works. It's 3 a.m. Yes, one of them is here. Oh, baby. I didn't even know shift.out exists. Okay, let's delete everything. Then do this a little more programmatically. Okay, now they should all have different positions on the z-axis. Oh, and they came back. Oh, that's because I need to always redraw the shift. Makes sense. Not doing it with a loop then. I'm going to do it the noob way probably and shift each of these by just a little bit. Oh, doing it in Vim is insanely hard. My fingers are breaking. This could be the one. Does it look good? I realized that someone smart would have probably created all of these with a loop, but you know, we're not about that here. Do they look separate from this angle? That's a good question. What if I shift the axes to the right? Shift right times 4. They should end up here in the middle. Okay. No, that still makes it look weird. Maybe this article might help me. Maybe it will tell me how to spin the axis. Does that work? If this works, this might be just the best website. Oh, that definitely did something. Okay, let's not rotate by 90 degrees, but let's rotate by maybe 10 degrees. Ooh, so it is rotating around the z-axis. Okay, so I want to actually then rotate about the y-axis, which is either right or up. Let's just try right instead. I wanted to rotate around the y-axis so that I can see more of the waves, just like here. Oh, this time it rotated about the x-axis, which means that the only thing I have is the up one, up, and let's make it 30 degrees. Oh, yes, this is exactly what I want. Okay. What else? Let's move the camera slightly down. In this case, I think it's phi, right? Oh, I don't want to mess with these again. Let's see what we get now. Yes. It's a lot more like it. Can we see the waves separately? I wouldn't say so. I mean, we can, but I'd like them to be a lot more separate. A lot more. Oh, what happened here? Can we see the separate waves? No. Why are they not separated now? So we fixed the wave problem, but there's more problems. Are they shifted? Can't really tell. This one seems to be closer. They are, right? Yes, they are. Just weirdly. Yeah, they seem to start off at different places, but not on that z-axis. They're just starting off weirdly in this line. So yeah, it only rotates the axis and not all of these curves for some reason. Why would it not do that? Let's also do x length equals like 10. I think I'm going to have to copy this entire thing and then paste it next to each of these to make my code even more readable. So paste it in here to rotate the sine waves as well as the axis. In theory, it should work. Oh, not sure what that's doing, but I can definitely see the waves separately now. Whoa, it's transformed them in a weird direction. So now if I do the normal transform, transform and also say that at the same time, inside of this transform, it should do all of this. And then this gets commented out. So right now I've put the transformation of the white curve into all of these separate curves into the same command as the command that changes the value of the value tracker, which technically means that these curves should start moving as it's transforming. Probably. Wow. What is this mess? If it works, we don't care about the mess. Ooh, I should then also rotate the white line, not only these ones. Okay, let's see what's happening here. Oh, it's happening, but it's happening very slowly. Wait, I don't remember how to put runtime into the same command. Just maybe I can do this and it might still work because this has runtime equals 2. Okay, I also commented out the entire axes, so they shouldn't be on the screen anymore. Oh, it's going now. Oh, and it still transforms very slowly. Why? Okay, here we go. This completely destroyed the animation for some reason. Okay, it's moving, but then it's slow again. But do these start moving? No, they don't. What happened? Why are they not moving? I think let's go back to how it was before I uncommented this and see what happens. Do they start moving or do they not? If they just randomly stopped moving once I changed something here, then we have a problem. And they're moving. Nice. So when I do it separately, they move, but when I do them not separately, they don't move. How do I make this replacement transform and this command happen at the same time? To make the white function not too jumpy in the middle, I'm going to say plus np.randomRand, which will add a random number to each of these sine waves. So hopefully their phase will shift and it won't interfere in the beginning and we won't get that super large wave. Oh, something else is happening. Interesting. Why did it turn to this? Why is it all weird? Let's do an integer instead from -20 to 20. Oh, what's this? Oh, I'm not adding it at the right place. Oh, now I get a lightsaber. Cool. Let's undo everything. So now the biggest problem is figuring out how to do this at the same time, how to transform from this white wave into those many waves with them starting to move as soon as it starts transforming and not later. Oh, screwed something up again. Okay, why is it not moving now? Huh? Okay, what if I put this runtime inside here but keep these two separate? Will that work? No. Oh, that's because I didn't put it where it was supposed to be. Okay, and so now if I transfer this over here, no, it just stops moving. Huh? What is this behavior? Okay, I have one more try. One more thing I think could work. So let's do everything with a loop, and instead of transforming from this graph into all the functions here, let's transform into each one individually. There's no chance it works. Okay, so after these self.play commands run, no, that will still not work. What am I doing? Okay, let's delete this one. Yeah, so I just don't know how to make it start at the same time. I don't know how to make it so that this white wave transforms into all of the other waves and it continues moving like this. Wait, what if the value tracker just changed to something like -5? And this would be like 3, maybe 2. And so now instead of this runtime, I could just do this. What about this? Now everything will happen over a period of 2 seconds, so this as well, but it will not move the waves as much. So this is moving fast, and when they transform, they should start moving slowly. Nope. Is it even possible to do that? What if I switch them places? Maybe that will do something? But this is what we have so far. It's not horrible, slightly horrible. Oh, now it stopped working again. Why? So it randomly starts and stops working. Also, these two commands just don't work in the same self.play command. They just don't work. It stays frozen and then it's like this. No movement. I don't even think it's possible to do it any other way. And I'm pretty happy with where I've gotten so far. So I think this might be my final animation. The one that's going to play. Boom. Here we go. Here's this wave and then it turns into these and these start moving like so. Not the best. Maybe let's make them slightly faster and increase the X range. Okay, and let's actually make this 4K 60 FPS, super smooth. This export time is going to be insane. Doesn't seem like it's exporting in 4K. Wow, this is like expectations, reality. Oh, it looks so bad, but that's my recreation. Maybe seeing it in 4K will increase the quality. Ooh, look at how smooth that looks. Okay, there we go. The final result. Perfect replica. 1-to-1 recreation. There isn't a single pixel that's different from this animation and this animation. Wow, I know. That's quite impressive. By the way, if you want to learn the basics of Manim, not how to do this, but the basics, how to write cool text on the screen or animate some basic shapes, then feel free to check out my Manim for Beginners course in the description. It doesn't require you to know anything about coding. Clearly, clearly I don't know anything, and inside the course I take you... What do I do inside the course? I'll take you through some simple projects that will help you learn the basics of Manim, and you'll be able to spice up your videos with cool animations, just as cool as this one. Oh, and there's one final thing I forgot to mention. Psych.